We're going to continue to talk about exponent rules. So today we're looking at the quotient rule. Remember that quotients are the answer to a division question. So if we look at this example and write this as repeated multiplication, we'll see that we have 5x's all divided by 2x's. And because this is only multiplication and division, we can simplify by dividing out these two x's, and you see that we have x cubed left. We subtracted the exponents. So when the bases are the same, we can keep the base and subtract the exponents. So our rule, when dividing powers with the same base, keep the base, subtract the exponents. Let's look at some examples here. Remember, when our base is in brackets, we need to keep it in brackets. 6 minus 4 is 2. Negative 4 all squared, positive 16. Now, when you look at the next one, we could think of this as separate fractions if we wanted to. We could think of it as 9 over 27. That needs to be simplified. Our powers with A separately, and our powers with B separately. So 9 over 27, 9 divides into each of these 3 times into 27, so we're left with 1 over 3. Here, I can see that I have 5 a's in the numerator, 1 a in the denominator. 5 minus 1 is 4. 8 b's in the numerator, 4 b's in the denominator. 8 minus 4 is also 4. So we have a to the power of 4, b to the power of 4, all over 3. Now I wanted to look at x cubed divided by x cubed in 2 different ways. First of all, we said if we multiply this out as repeated multiplication, I can see that my x's all divide out. And I'm left with 1 times 1 times 1, or 1. Because of course we know as long as x does not equal 0, a number divided by itself is always equal to 1. But let's use that exponent law we were just talking about. Keep the base and subtract the exponents. This is x to the power of 0. X to the power of 0 equals 1. In fact, as long as x does not equal 0, any number raised to the power of 0 will always equal 1. I wanted to look at that with you in another way. I know you don't have this in your notes, but let's do this here. Oh, I think my 2 to the power of 0 went on to the next page there. There we go. So we know 2 cubed equals 8. 2 to the power of 2 is 4. 2 to the power of 1 equals 2. In mathematics, there's always a pattern that we're looking for. And we can see that the pattern from one question to the next is that we're dividing by 2. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 equals 1. So there we have it again. A number raised to the power of 0 equals 1. So in your notes, we say a to the power of 0 equals 1, but only if a does not equal 0. So that's important. 0 is always a problem in mathematics, and we need to pay attention to 0. So can you pause your video and answer each of these. Remember, in the first case, we have a product being raised to a power. That means we have 2 to the power of 0 times x to the power of 0, which is just 1 times 1, or 1. What did you get for the next one? Did you remember that that power of 0 is only applying to the x? -7 times 1. That equals -7. And here, 1 plus 1 equals 2. So let's use those rules that we've been talking about and simplify these 3 expressions. In the first one, remember we could open those brackets and change the order of multiplication. 2 times -8 times x cubed times x to the power of 4. The important thing here is to remember that this is multiplication. So we have -16, and keep the base, add those exponents. What about in the next one? We have that fraction of 3/9, base of x, subtract the exponents. The fraction can simplify, of course, to 1/3. I'm dividing by 3, dividing by 3. And keep the x, subtract the exponents. Why don't you pause the video and try the next one? I hope you simplified this first. Remember that BEDMAS? Brackets, exponents. We always solve inside the brackets first. Well, we can certainly simplify that 4/6 and then raise it to the power of 3. Now, everything inside the brackets raised to the power of 3. Did you get 8 times y to the power of 15 all over 27, x to the power of 12? I hope so.